Okay, in this video, I'm going to talk about something that will be on the final, because we're giving the same final as our other Algebra 2 classes, and something that we haven't talked about in class is imaginary numbers. This will show up in the final, so I'm going to show you some examples of it so that way you're ready for it when you see it. So as some of you have discovered when solving other problems, especially with the quadratic formula, if you've tried to put in the square root of a negative number, your calculator gave you an error. And that's because when we're finding the square root of a number, we're trying to find what numbers multiply together times itself to get that number. So for example, the square root of 4 is 2 because 2 times 2 equals 4. However, we can't find the square root of negative 4. You might think that it would be negative 2, but negative 2 times negative 2 does not equal negative 4, it equals a positive 4. You cannot find the square root of a negative number. However, there are some applications where it would be helpful to be able to work with them, and so that's kind of what these imaginary numbers are for. The imaginary unit is I, and it is defined as the square root of negative 1. So the square root of negative 1 is what's considered an imaginary number. And all it is just a notation to help us kind of work with the square roots of negative numbers. When we were working with imaginary numbers, we're going to have them written in the form AI, where A is the real number, so the part that we can kind of know how to work with, and then I is the imaginary number, the part that we can't really work with as well. So when given a number, in order to work with it with imaginary numbers to turn it into something that we do know how to work with, we're going to rewrite the square root of our negative number as the square root of negative 1 times a. So essentially just turning our number into a positive, but keeping this negative 1 as part of our square root. For step 2, this is really where most of our work is going to come, and it says to break down a if a is not a perfect square. So things that are perfect squares are numbers that you can get by taking a number times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and if you keep going, 4 times 4 would be 16, 25, 36, 49, 64, 81, and 100. These are the perfect square numbers. What we're going to be looking for is these numbers, or can we divide the numbers that are inside of these radicals by one of these numbers? Because if we can, that will also help us. So let's look at some examples. For number 1, we have the square root of negative 9. So the first step would be to rewrite this as the square root of 9 times negative 1. Just want to break it down into, instead of negative 9, we'll break it into 9 times negative 1. Now you can break a square root if you are multiplying two numbers together into two different square roots. So you can say that this is the square root of 9 times the square root of negative 1. Okay. The square root of 9, we know how to find. You can put that in your calculator if you weren't sure. But the square root of 9 is 3, because 3 times 3 equals 9. And the new thing that we've learned today is that the square root of negative 1 is the imaginary unit. So this is I. So for this one, that is all we need to do. Turn this negative 9 into the square root of negative 9 into the square root of 9 times negative 1. Break that down into these two square roots, the square root of 9 times the square root of negative 1. The square root of 9 is 3, and the square root of negative 1 is I. So our answer will be 3i. So then let's go on to number 2. We have the square root of negative 196. So I'm going to start by saying that this is the square root of 196 times negative 1. Since those things are being multiplied together, I'm going to split it into two square roots. The square root of 196 times the square root of negative 1. The square root of 196 is 14. Again, you can find that by putting it into your calculator. But the square root of 196 is 14. And the square root of negative 1 is I. So we're going to get 14i as our answer here. For number 3, we have the square root of negative 5. So I'll start by saying that this is the square root of 5 times negative 1. Break that into the square root of 5 times the square root of negative 1. Now 5 is not a perfect square. It's not one of these numbers over here, the 1, 4, 9, 16, 25, etc. It's not a number you can get by multiplying the same thing by itself. So that's actually the square root of 5 cannot be broken down at all. So we would still just have the square root of 5 here, and then the square root of negative 1 is I. Here, we will need to make one change, and that is that I should go in front of any square roots in our final answer. So if we have a square root that we can't break down any further, the I should go in front of it. So it would be I, the square root of 5. Okay, so number 4, we have the square root of negative 80, which we're going to start by turning into the square root of 80 and the square root of negative 1. Now 80 is not a perfect number like the ones we've been working with on the past ones. It's not, one of these numbers you can get by multiplying the same number times itself. So what we need to do is see, can we divide 80 by one of these numbers in order to break it down? So we could divide 80 by 4 and get 20. So we could break it down into the square root of 4 and the square root of 20, which would help us break it down. However, that's not the biggest number that we can divide it by, and so we want to find the biggest one. We can also divide 80 by 16, which is 5. 80 divided by 16 is 5. So I can break down the square root of 80 into the square root of 16 times the square root of 5. And then I'll bring down this square root of negative 1. Now the square root of 16 is 4, because 4 times 4 is 16. The square root of 5 I cannot break down anymore. And the square root of negative 1 is I. Here, remember, just like on the last one, if we have a square root that we cannot break down any further, the I should go in front of that. So instead of being 4, the square root of 5i, we're going to write it as 4i, the square root of 5. So then on to number 5. We have the square root of negative 32, which I'll start by writing as the square root of 32 times the square root of negative 1. Again, 32 is not a perfect square, so I can't directly just take the square root of it yet, but I can see if I can divide it by anything else in this list. And I can divide 32 also by 16, and that is the biggest one that we can divide it by, and that is 2. And so that will give me that the square root of 32 can break down into the square root of 16 times the square root of 2, bring down the square root of negative 1. The square root of 16 I can break down into 4, 4 times 4, and the square root of 2, okay, I can't break down, so that'll stay the square root of 2. The square root of negative 1 is I. Once again, since we can't break down that square root of 2 to anything else, the I should go in front of it, so we'll have 4i, the square root of 2. And finally, for number 6, we have the square root of negative 192. So I'll first write that as the square root of 192 times the square root of negative 1. Go back over to the list to see if 192 can be divided by any of these things. And there are multiple, but the biggest one that the square root of 192 can be divided by is 64. 192 divided by 64 is 3. So I could break down the square root of 194 into the square root of 64 times the square root of 3, and then the square root of negative 1. The square root of 64 is 8. Square root of 3, and then the square root of negative 1 is I. And as the previous two, we should rearrange this to say 8i, the square root of 3. Let me see if I can make a better 3 there. Okay, 8i, the square root of 3. So there's some examples of how we can break down the square roots of negative numbers into things that are easier to work with. What I want you to do is go down to the assignment where it says Unit 4, Homework 4, Pure Imaginary Numbers. And I want you to do the first 8 problems. So just the first 8, and then you can move on to the next video. If you have any questions or anything or need help, let me know.